Alright everybody, welcome back to video number 2 for section 7.2 of AP Calculus, verifying solutions for differential equations. We're going to pick right up where we left off. In the last video we closed with an example on verifying a solution to a differential equation. We're going to look at 3 more examples in this video, utilizing concepts that are important for verifying these solutions. So let's go on to example 4. The question of the following, which are solutions to the differential equation y double prime minus 4y equals 0. So in order to answer this question, to see if it is a solution to this differential equation, we're going to need the second derivative of all of these functions. So that's the first thing I'm going to do, is I'm going to go ahead and calculate the first and second derivative of all of these. I start with choice 1. The first derivative is going to be negative 6 sine of 2x. And then the second derivative is going to be negative 12 cosine of 2x. And now in order to see if it's a solution to this differential equation, I can just go ahead and substitute y double prime and y into this equation and see if it makes it true. So I'm going to put y double prime in, negative 12 cosine of 2x minus 4 times 3 cosine of 2x. And our question is that equal to 0? When I distribute this out, I get negative 24 cosine of 2x on the left-hand side. And so no, this is not a solution to the differential equation. All right, let's look at choice II here. We find y prime. Taking the derivative of that, we get y prime equals e to the 2x. And then y double prime is going to be 2e to the 2x. And so now we substitute that into our equation here. So we put 2e to the 2x in for y double prime and 1/2 e to the 2x. And we're wondering, is that equal to 0? Doing the algebraic manipulation here. Bada boom, bada bing, we get 0 equals 0. And so yes, this is a solution to the differential equation. All right, last one, y equals ce to the 2x. Again, going to follow the same general pattern. I'm going to find the derivative. It's going to be 2ce to the 2x, since c is a constant multiple. And y double prime is going to be 4ce to the 2x. And so substituting that into this, we get 4ce to the 2x minus 4 times ce to the 2x. And we're wondering, is that equal to 0? And if we do the arithmetic, we find out that it indeed is equal to 0. And so my answer here is going to be yes. This one does point out something very interesting, that in general, any function of the form y equals ce to the 2x is a solution to this particular differential equation. All right, let's go ahead and we will move on to example 5. All right, example 5. For what value of k, if any, is y equals e to the 4x minus k e to the x a solution to the differential equation y double prime equals 4y prime plus 6e to the x? Okay, so let's go ahead and we'll take the derivative of this. So y prime is equal to 4e to the 4x minus k e to the x. And y double prime is equal to 16e to the 4x minus k e to the x. All right, and now we're going to substitute both of those into this differential equation in the appropriate spot. We start with y double prime on the left-hand side, 16e to the 4x minus k e to the x, and we want to know, is that equal to 4 times y prime oh wait, I can get rid of that question mark. I'm looking for the value of k that makes this true, so there is going, well, I'm assuming there's going to be a value of k that makes this true. All right. And now let's see, do I have everything set up right? Y double prime equals 4y prime plus 6e to the x. Okay, now it's calculating time. On the left-hand side, there's not really anything for me to do right now. I distribute the 4 on the right-hand side. And now I can go ahead and try and simplify this. I can subtract 16e to the 4x from both sides. And I can add 4k e to the x to both sides. And that gives me that 3k e to the x is equal to 6e to the x. Dividing both sides by e to the x, we get 3k equals 6. And so the value of k, for which this function right here is a solution to this differential equation, is 2. All right. Last example, if y prime equals 2e to the x plus y and y equals 2e when x equals 1, then which of the following is a solution to the differential equation? So we have this initial condition that y is equal to 2e when x is equal to 1. That's the first thing I'm going to do, is I'm going to check what happens, at x equals 1. At x equals 1, this is e squared plus e, but it should be 2e. Okay, so I can eliminate this as an answer choice immediately. I do the same thing at this one. At x equals 1, this is 2e. So that one's still alive. That could be our answer. I do the same thing for this one. At x equals 1, this is 2 plus e. So again, I can eliminate that as an answer choice. And at x equals 1, this one is 2e, so that one's still alive. So I could eliminate both of those choices A and C just by using the initial condition. Okay, and now I'm going to go ahead and take the derivative of these. If I take the derivative of this, I get y prime equals 2e to the x. And if I take the derivative of this, I get y prime equals, 2x e to the x plus 2e to the x. If I rearrange that, it's 2e to the x plus 2x e to the x. So notice we're trying to match this up with y prime being equal to 2e to the x plus y. If this matched up, that would mean that for this one, does y equal 0? The original function. And it doesn't. And so at this point I can eliminate this. So D should be our answer. If we go ahead and look at that, y prime equals, there's my 2e to the x. So this should be equal to y, the original function. And ta-da, it is. And so that is our solution. All right, that's the end of our lesson on verifying solutions for differential equations. For those of you who are my students, there are some practice problems for you to do, and then there's a quiz as well. So go ahead and make sure you complete those. And we'll see you next time, everybody, for section 7.3, sketching slope fields. All right, have a great rest of your day, everybody. See ya, enjoy yourself, and goodbye.